Yeah. Very good evening to all the faculties. Welcome you all once again for the faculty development program on data analytics with IBM Cognos for day 4. So, dear participants, we are going to start with today's session in 5 minutes. So I request to other faculties to please call to the other faculties to join the session immediately so that we can start with today's session. So thank you very much. We will start the session at 6. Thank you very much. So a very good evening once again to all the faculties present here. So now I request to Mohan sir to please start with today's session. And today's we have an hands-on in IBM Cognos platform. So I request Mohan sir to please start with today's session. Thank you very much, sir. And over to you, sir.
Thank you and good evening, Shubham. Very good evening to all our participants. Hope I'm audible to all of you clearly.
Yes.
Welcome to day 4 on the faculty development program on data analytics with IBM Cognos. We'll start for the proceedings and activities on day 4, a brief agenda. In the last session, we could discover a very basic overview of exploratory data analysis and how Cognos uses the impeccable features within it in order to discover rich insights via visual schemes on a simple real-world use case. We would continue the session as discussed. We would take it further long. We would try to discover more data artifacts through visual insights on a bit more complex scenario than the one that we worked in last session. We would do the initial EDA part followed by data pre-processing, which is due on day 3. We would realize 2 important facts: how EDA alongside with data pre-processing can add more value to analytics before data are moved forward for modeling, predictive or prescriptive modeling. Welcome everybody once again to the day 4 on this FDP. I have shared my presentation with you all participants. Please confirm, could you see my technical presentation clearly? Is it visible to all of you?
Yes, sir. It's visible.
Thank you. Continuing our discussion on data visualization, today also we'll steer the session with data visualization. To give all a quick recall on this evening of Monday afresh. One has to understand why visual practices add more value in data exploration. Because when we are dealing with voluminous, varied, and uncertain data, a better approach is to, besides application of statistical techniques and methods, visualizations add more value to our analytical project experiments. Once again, we'll have a recap of a quick glimpse of which type of visualization need to be applied or selected for what type of data. To start with, as a data analyst or researcher, if you'd like to measure or assess the individual parts of data items of a problem in relation to the whole data, that is, if you wish to, for instance, if you wish to compare the quarterly sales of each quarter over the annual sales, for such type of project requirements, you can prefer the pie chart or a stacked bar or column or even an area chart. These are the typical visual tools that would aid the data analyst to understand how to project a visualization in order to compare an individual part of a data to the wholesome data. Similarly, if one wants to study the distribution of data, generally data distribution comes into effect when the researcher or observer is interested to examine how data are spread out in the real world. The objects or data items that are suitable for distribution of data analysis typically are continuous data item, that is numeric in nature, because most of the real world data are numeric, will have a definite spread around it consisting of inherent variance and standard deviation. There are also probability for the observer to examine, investigate peculiar trends and unexpected, unidentified anomalies or deviations called outliers. For all this rigor, the data analyst can prefer to work with visual tools such as scatter plot, the line chart, column chart, and the bar chart. So one can use to study, examine the distribution of data over these. Added to this, we also have value-added advanced plots like box plots that can measure big data, voluminous and varied data very effectively other than these regular charts. Then the next category of visual tools that one has to understand, whenever raw data are equipped with date and time parameter, or when real world transaction data includes the date time attributes, preferred charts might include a line chart. Or if you want to study certain correlations, statistical correlations among data by time, we can also project the visualization as a heat map, or we can also use column chart. So that's why if you see, column chart or bar is the most widely used one for measuring the relationship for qualitative or quantitative data items. That's why they are the default data visualization schemes in most of the analytical software. If one wants to measure a relationship that would exist, relationship here means the strength of association or simply correlation. If we would like to discover that, again, we can go ahead with scatter plot or scatter chart, and most robust bubble chart that would establish the relationship between a categorical variable and also its continuous measure. And finally, if you have any geographic or location-based data, tools like Cognos, Tableau, and Power BI, and all value-added analytics tools in the market, they provide specific, specially designed geographic map-based visualizations that could crunch a lot, synthesize a lot of location-based, longitude, latitude-based data using a geographic map-based visualization projection. So these are the typical know-how or prerequisites for all of us to understand before we further go on to part 2 of our data visualization practices with much more complex real-world data scenarios. So now I would request all of you to connect to the Cognos analytics tool. I'm already logged in here. You can see that. All the participants are requested to connect to your IBM Cognos Analytics account credential. We would now pick up the second data set that we were supposed to work with on data exploration, followed by data pre-processing also. But before that, I would like to know from our participants, could anybody give a try on the second data set named bike buyer 1.csv? If so, could you find anything, something typical? Yeah, Zoebji has tried. Thank you, sir. Keep it up. Very nice. So Zoebji, could you please share your observations named bike buyer 1? Others who could also try. Yeah, the size of this data set is very huge, right? Yeah, you can share, Joebji, if you want to show us something, your observations, or you want to share your idea, you could share, please. Ayushi also tried. Very nice. Yeah, we are now viewing Joebji's screen. Yes. So comment on the data set, Joebji. Initially, what are your key observations on it? Acha, you could generate some exploration for us. Great.
So there was only two columns where I could do some correlations because and there were many things. The one thing that I found very intuitive was that the people were having some occupation and then their yearly income.
Great, sir.
Other columns I was not able to correlate how the trend is changing between them.
Right. Very good. Very nice to see the initiation. We will guide you through how to do the visual analytics on the EDA part of this data set. Any other participants who could give it a try? Please share the screen. Ayushi, what about you? Could you just explore something? And any other participants who could just discover like something is there in the data and what is it all about? Okay, no issues, participants. I'll just give the required knowledge transfer. Permit me to share my screen once again. Yeah, I hope you all can see my IBM Cognos Analytics screen. Already, yes. We could upload the data on the day 2 on Cognos platform. So I just would like to view this data here. So what I do is I'll try to create first a data module. To view the data, I just would like to take the help of a data module. I will load my CSV file of bike buyer into the data module. So here I have my data module object, which is a fundamental building block for most of the analytical explorations, dashboard building, report management, story building, etc. I hope all participants could clearly see the raw data in the data module grid. What is this data? Let us just venture into this project. There is a automobile manufacturing business firm, typically the two-wheeler bike manufacturing firm. The production engineering team would try to put forward some raw material into the supply engineering chain and then manufacture, produce, advertise, and sell bikes. Knowing this line of business, one of the typical challenge for this organization is before the product is designed, manufactured, and then released into the market research analytics team in this organization is planning to know in advance whether the customers or respondents in the market, how likely or unlikely are they to buy the bike. I mean, are customers really interested to buy the automobile two-wheeler bike product? Do you think, participants, is this a very important KPI in order to know before actual production engineering starts? What do you say? Should the marketing team or market research team should throw light on this question? Yes, because today we are in a competitive world and choices to the customers are many and any. If you want to sustain and survive our businesses, we must do some preliminary investigation, or typically called need analysis of the market. How to conduct that need analysis, what activities to be carried out, we shall now discuss. The market research analytics team met some respondents in the market, around 7,000 respondents. They met with some questionnaire through a survey questionnaire. In the survey questionnaire, certain data was collected against some questions regarding the demographics, the behavioral psychographic data of the end user. Such data includes the ID of the respondent who filled the questionnaire, marital status of the individual or respondent who was contacted or met, gender, yearly income, number of children the individual or the respondent has in the family size, the education level of the individual again, whether they are a school graduate, whether they are a school going or high school, college, or graduate degree, partial college, or further higher education. The job occupation of the individual, similarly, whether they own a home or not, that is whether the individual who was contacted, whether he or she is a home owner or not. A no indicates that the individual doesn't have a home. Yes indicates the respondent is a home owner or owner of a house. The cars column, as you can see here, typically indicates at a numerical value whether the respondent possesses any four-wheeler car or not. 0 indicates the individual doesn't have any cars currently. Other numbers indicate the respective quantity. Then similarly, commute distance, that is how much distance the individual travels in a day. This is measured in miles. The distance is measured in miles, and the region which they live in or belong to, age of the respondent in years, and finally one column, one question they would like to know from the respondent whether that individual is interested to buy the company's bike or not. Now, if you look at the column bike buyer, the labels associated or the class labels associated are some individuals responded positively or favorably by saying yes, while other individuals in the market survey responded unfavorably or by saying no. Now, our challenge here in this research problem statement is, do you think, first of all, what is the objective of the observer or data analyst in this data set? As discussed straightforward, the analytics team or research team would like to know whether the end user will buy bike or not. Already we got the responses yes and no. But what else we have to do is, if bike buyer is our target feature or variable in the project, we have to explore and discover today what makes a respondent either favorably respond, that is say yes, or unfavorably respond no to our question. Given this hypothesis, research hypothesis, what parameters do we think are driving the response of the individual? Whether it is marital status, whether it is gender or yearly income or children, etc., or all of these predictors together, how are they driving the affecting the decision of the bike buyer is what we are now going to explore in depth on this project named prediction or exploratory data analysis using market research analytics of automobile bike manufacturing firm. So that's the discovery that we have to do. Before we plunge into our EDA, participants, use your basic exposure and analytical common sense practices and tell me how many of these given parameters in the data set do you think might psychologically have an edge over the target variable? Do you think marital status of an individual can be one of the significant factor or reason in order to say either yes or no towards a bike purchase? So what is your general opinion about it? Can we admit that marital status can be one of the important predictor? Yes, Zoebji and Ayushi ji says yes. Others also, I would appreciate if you can just respond with yes or no in the chat, dear participants. Great, yes, can be one of the factor. Similarly, gender, do you think can have some business with the bike? Because in last case studies, we see how gender was very uncertain variable, but at the end of the case study, we discovered how important it is. Correct. Gender can also be probably one of this, but still we don't have any evidence to claim our hypothesis. These are all our null hypotheses that we are assuming it. Then, how many of you opine yearly income can be a significant predictor or variable? Without income, we cannot do anything. That's why we strongly believe that we can presume that income can be one of the predominant variables in driving the decision comparatively to marital status and gender. Likewise, we can build a hypothesis around each variable against the target variable. So as many variables are given in the data set, that many hypotheses can be built out for a exploratory data analysis. And finally, we could discover which are significant predictor, which might not be the one, so that we can use the significant predictors or variables in our predictive modeling, while we can discard or exclude the least significant ones from the research modeling. Given this basic understanding, what else do you find peculiar in this data set? Anybody? Observe some columns and some peculiarities. Do you find anything particular, peculiar, or something interesting? If you would open your raw data in Excel sheet, participants, like let me just show the raw data for you all here. I am opening this in Excel format for you rather than in Cognos for some very key observation here. Can you all see my Excel screen? Let me share it again. Yes. Could you all clearly see my Excel workbook here? That is the data named bike buyer 1.csv. Everybody? Great. Now check out the columns: ID, marital status, gender, yearly income, right? Some column names are there here. What do you find peculiar in this? Yeah, everybody. Anything interesting in this data? I already explained what is this problem and what is our target variable objective. If you carefully observe the data column by column, for example, first column is respondent ID. If I just highlight this cell here, right? Could you find any value absent here, participants? Please check out. Let me annotate here. Yes, I am highlighting this cell. Please check out. Do you find something unusual here? Yes, there is no ID here. You're right, Zabji. Very nice. There is no ID. It is blank. It is empty. Similarly, if I take marital status column, there is something missing here. See, empty value. There is no marital status information about the respondent. Likewise, if you see gender column, there is something missing here. Such data are raw data actually. So in real world practice, not every collection of data set is 100% correct and complete. Data are partially complete and consistent. That's why the greatness of exploratory data analysis is it could allow us to discover these deficiencies in the data. Incomplete, incorrect, inconsistent data should not be directly taken forward for predictive or prescriptive modeling. That would lead to biased analysis. That's why care must be taken to do in-depth data exploration and proper data pre-processing in order to make sure data are suitable for analysis. Also, if you see the yearly income column, all of you here, one of the respondents' yearly income is 0. Do you think this data point can be believable? Can a person's yearly income be 0? Yeah. Sometimes it can be 0 or may not be 0, right? Whose income can be 0? In a real world data environment, against yearly income, it cannot be 0, provided if an occupation is there. Nice observation, Zoebji, once again. Occupation was mentioned as clerical, but the data point was mentioning a 0 clerical income. Don't you think this is too much in the data? Such an uncertainty is called noise in the data, or typically we call this data in real world as noisy data. The data is leading to confusion or biasedness or uncertainty. That's why this simple data set, what we are today working in real time, is a voluminous data. It has different varieties of columns, and it also has veracity in it. Veracity means uncertainty. That's why the real world data are today called as big data. To handle the challenges in this big data, our only unique solution is to conduct rigor analytics on this data to offer real solutions. Likewise, there are many inconsistencies or incompleteness in this data set. So if we connect such a data set to our Cognos platform, how does that recognize? For instance, now I'm closing the Excel sheet. I hope you all understood the essence of the Excel. Now I'm connecting to my Cognos screen. You can see here the Cognos platform. when incorrect, incomplete data are connected to any analytics tool, you could see the absence of values are depicted by a notation called null. Aishuji, you have written correctly, null. Null is an identifier that indicates there are some absent values. Typically, these absent values are called missing values in the data set. Now tell me, do we need to explore this data to discover more disturbances and then take some preventive measures to clean this data or not? Given such a data at hand, the two-step process in the exercise is exploratory data analysis followed by data pre-processing. Data pre-processing is a very bigger word. Under the umbrella of data pre-processing, there are many activities that I'm going to elaborate one by one in detail, both theory and hands-on. But we will confine to data cleaning. Yes, you're right, Zabji. We need to handle the data. We should try to fill some value, means we need to handle the data in a proper way that it becomes suitable for analysis. So I hope all of you are clear about this one. To begin with, let's start exploring this data. How do we explore? Click on your open menu, click on the new command button, and then start exploring your data. Click data exploration. To proceed with exploration, please provide the data set as input. Where is the data set available? It is under my content folder or repository. This time, choose our input data set as bikebuyer1.csv. You can connect the data set to data module and then explore, or directly you can proceed with the data set and start exploring it. So I choose my required data item as bike buyer and click add. Now I'm redirecting to exploratory data analysis section. As you recall, first click on open menu. This is open menu, and click new command button. As you all can see, when you click the new command button, you have under the menu item explore called exploration. Once again, participants, click on the open menu on top left corner. In the drop down, click on the new option. In the new option, the activity that we are going to choose is exploration. So please click on exploration. This exploration will make us redirect to the exploration page. Hope everybody is in the exploration page. Who are doing hands-on, please confirm, participants, so that I can proceed further. Everybody is currently on the data exploration page. Right. Thank you, Sharabji. Everybody. Recall our last session of EDA, basic EDA. We all know Cognos being a very highly AI-powered tool, there are multiple ways for us to explore. You can start with some suggestions offered by the tool, or you can go ahead with your own exploration by selecting the required parameter of your choice or variable. Alternatively, you can use the Cognos assistant. Just click on the assistant, launch the assistant, and type your natural language queries, like simply asking a plain English question, and run your query. Right. For example, if you like to see total yearly income, if I just type total yearly income, I just get ahead of the certain queries, and I would like to just run my query here. This would process my query and produce me with the total yearly income. The total yearly income is being processed $399 million US. So this is the total yearly income. Thus, by using the search query or using the Cognos Analytics Assistant, we could start discovering some key insights. But a very basic way to start is, like, we would like to check our target variable, right? So what is our target variable here? From the search list, you can walk through and find out your target variable, that is bike buyer. In the search query, please hit on bike buyer, and Cognos immediately produces something. What is the name of this construct? Anybody? We discussed in the last session. Just recall kindly. There is some structure that is being created. Thank you, Zobji, for your continuous and perfect answers. Request all the participants to be interactive in the chat for a very enriched session. This is called the relationship diagram. For information, you can take a note of it who need it. This is called the initial relationship diagram, right, Sharadji? The relationship diagram is a measure of how the target is being influenced by other predictors. Surprisingly, if you see, there are many columns in our data set, typically 12 to 13 columns. But we could see in the relationship diagram only some of the parameters being displayed. Why? Cognos Analytics is not projecting all the data items in the relationship. Probably anybody? Maybe the tool understood the statistical correlations or relationships, inherent relationships, and found that these are the whatever are the entities included in the relationship diagram, probably they might have more significance, inherent statistical relationship with our target. But this is only just a high level vision of the tool. In order to believe whether these entities that the tool recommends are really significant and why others are not included, we have to take a journey on each and every column. Recall the framework of the data analytics. Our journey starts with examining each individual variable in the data set, followed by the dependencies. So if we examine each independent variable in the data set, the technique is called univariate analysis. If you would like to study the dependencies between two variables, that can be termed as bivariate analysis. Further to, we can also do multivariate analysis also. So to start, after this relationship diagram, I would like to continue creating my visualizations for exploring data. So let's start together. Click on create button, and to project a visualization, let's start single visualization. First of all, let's go with some ad hoc assumptions for our project. As shown by the relationship diagram, number of children, gender, or cars variable, some of the tool understood variables, commute distance, we believe that the tool is trying to diagnose the significant predictors correctly. Let's hope, let us build some visualizations around the most important predictor that the tool suggested. Alternatively, you can select your required variable also as an entry point for exploratory data analysis. So let's start picking up choose a type. When we click choose a type, you could see how Cognos presents you with a plethora of visualization tools that you can include in your EDA setup project. So first, I would like to start with the demographic variables initially, that is gender. Gender, we just presumed in our hypothetical discussion how gender could be one of the most important predictor with some initial chance probability of gender affecting the decision. With the given knowledge discussion so far from the last 3 days, could anybody suggest me what type of visualization could be recommended to study the relationship between gender versus bike buyer probability? Sharadji and Zohabji recommends me a pie chart, while Ayushji recommends me a bar. Okay. Histogram, comparison, correct. Satyam Soniji says it belongs to the category of comparison, definitely. So correct, all our insights are rich. But let me give you all some assistance here for help. See, if you see our target variable bike buyer, how many classes of outcomes are there for it? Bike buyer can either respond yes or no. So it is binary in nature. You're right, Jobji. Two categories are there. Unlike our previous case study where the sales in rupees had only one fixed value, here we have two projections to be done. So if we take a pie chart or a bar chart, these two charts or visual tools can study the relationship between how gender, that is either male or female, are saying either yes or no. So two gender categories, male, female, two bike buyer categories, yes, no. How many permutations and combinations can we draw from them? A male can say either yes or no. Do you agree? Please reply with your yes or no. A male respondent can respond either yes or no. Similarly, a female respondent can also respond either yes or no. So one gender has two outcomes. How can we project a qualitative data item against two qualitative responses? So this is a typical challenge. So for instance, if I try a pie chart as suggested by our faculty participants, you can just see this. You need not try until I recommend the right chart for you. See for instance, I'm picking a pie chart participants. I hope you can see the skeleton of pie chart on my screen. So what I'm interested is gender. I'm trying to drag and drop gender into segments, and the target column I would like to measure is bike buyer. So I just deposit that in the size. Both are categorical data items only for information. If you could see that, both are categorical, right? Gender and bike buyer. So for the bike buyer, I would like to see the count of it. So I like to change the summarize function to count. Now, could you see here? There are two distributions in the pie graph. One showing some number here, 3,527 on the left hand side, which is a male category as per the Legends color code. One on the right hand side on a pink color, 3,441, saying that it is female. So the pie chart could study the distribution of male and female buyers, male and female respondents. But I have a question of concern here for our participants. Out of these 3,441 males, are you interested to really explore how many of them said yes and how many of them said no? Similarly, out of 3,527 participants are females, do you think you have to discover how many said yes and how many said no? What do you say, participants? Correct. So this pie chart, do you think is giving the required information against your research hypothesis or your research problem, or you need to further drill down the visualization? Aishiji, what do you say? Vishalji, everybody. This current visualization is not providing the required information for our research efforts. That's why, as I emphasize every day in this faculty development program, selection of the right visualization allows us to generate the exact insights of the data. That's why data visualizations prerequisites are very much required for every learner, whichever tool, even when you're working on Excel or any other analytics software. So after understanding that we could not get the real required insights, what I do is I now try to change my visualization type. Recall my presentation. What type of tool can fit for the multi-dimensional visualization? We can go for, yes, a bivariate analysis where the number of categories are more than one. Here, gender has more than one category, and we also have bike buyer. That's why rather than going with basic charts, but for a qualitative categorical representation, whenever you want to study the bivariate relationship between two categorical variables, please note that you can use either bar chart or column chart. But because the outcome variable has two classes, a simple bar and column might not be sufficient. That's why we extend our analysis to either stacked bar or stacked column. What is meant by stacked bar or stacked column? As the name says, stacked means lay out the data items one over the other or one beside other in relation to. I repeat, the word stacked means like piling up items one top of the other or one adjacent to the other, because those data items have certain inherent relationship. At this point, I would like to choose a stacked column chart. Now all participants can do the hands-on with me. Please select your visualization type for question number 1, gender versus bike buyer, as stacked column. Now this is the rough skeleton of the stacked column layout. I'll just keep this here. Yes. Now, what are we going to do? We need to pick up the bars. We need to specify the length, etc. So the graph type is stacked column. Then under the bars, we would like to discover the category. The category we are interested in is gender. So please drag and drop gender into the bars category. Or you can also put your target variable also, because categories need to be represented can be a target variable. Alternative, you can drag bike buyer target variable into bar section. Bars are nothing but the quantities or the qualitative items like yes category, no category, etc. Please drag and drop bike buyer variable, which is a qualitative data item with two class labels, which is our target, into the bars. Now tell me, as per our discussion, are you interested to count the number of males who said yes and no? Are you interested to count the number of females who said yes and no? If that is your research requirement, then drag gender into the length column. I repeat, participants, if our visualization should show us the fact how many males said yes and no, how many female gender said yes and no, then the length item should be the gender. Why we are putting gender in the length again? To quantify the count of male and female, to aggregate the count of male and female responses by segmenting them into yes and no categories. We are picking the data items into the structure. So we have bike buyer and gender. But if you see now, two projections have come on screen. One is yes, one is no. But further, we would like to refine this graph by choosing the appropriate aggregation or summary analysis. Hope all of you are done till here by placing bike buyer in bar section and length. Let's turn this into the count. So choose summarize, and this is count distinct actually by default. Change the summary function to count. How did I get that? On the gender section, you can click on the more button or actions menu button and then choose the summarize and choose count. Now this would change our graph. Would you now see your graph turning into the bike buyer distribution count? Initially, this graph tells the reality. What is the reality? That is, near 6,000 respondents said no, and only near 1,000 would have said yes. So the distribution of bike buyer by gender here is done. But we need more peculiar information. That is, by how many males said no and yes, how many females said no and yes. Could all of you get this graph, participants? Please confirm. All of you had this graph. Now to make it more realistic, that is by segmentation, to add more richness, I will drag gender to my color. I'll drag gender variable to the colorification. Yeah. Yes, I would see your graph, madam. Yes. Now, if you drag gender to the color, this created a stacked column chart for us clearly. This is called stack. Data items laid out one top of the other or one adjacent to the other. Now we could see on x-axis we have bike buyer classes yes and no, and each color code depicts a gender. The brown color on my screen corresponds to the male category, and the pink one corresponds to female category. Right? Quite simple. That's why selecting the visualization type will help you to produce the right kind of visual insight into your hypothesis. To make it more readable, to make it more interpretable, what you can do is, after creating this graph, yes, Zoebji, any question you can type in the chat, sir. I'll be speaking through and I'll be answering all your questions. Any question you can type in the chat. If I click on properties tab, after creating this graph, participants, everybody, please click on the properties tab on the top right corner, properties tab. And there is show value labels section. The slider is put off. Now we'll put it on, turn it on. When I turn on show value labels on the right hand side, could you notice the distribution quantities are now displayed as the labels on the graph? How did I get it? Just click on the properties tab on the right hand side here, where I am annotating here. You can see that properties tab, and under properties tab, the option that you have to turn on is show value labels here. Exactly. When you turn it on, you get this. Yeah, and under value label format, by default, we have value. Okay, that's why the values are projected. When the default is value, values are projected. When I turn this, when I just convert this into the other property, like such as choosing value and percentage of color. If you see, there are many different custom value and percentage of color. Could you now you see the value and percentage of responses are now being greatly displayed on your stacked column. So your question here is, we have graph, we had two variables, correct? We had two classes, Zoebji. Variable is only one, byte buyer is only variable. There are two classes, one is yes class and no class. We are trying to map how many yes classes of male and female, and we are trying to map how many no classes of male and female. That is how we have to understand the graph. Okay. Actually, target variable is only one item, byte buyer, under which two varieties are there, yes variety and no variety, that we are trying to study the distribution by gender. That's it. Yes, there can be more than two classes. Good question. This problem is binary classification, where target variable has only two classes, but in real world, target variable might have more than two classes, which is called multi-class classification. In such a case also, we can go for a tree map or a bubble chart. Please note down, whenever your target variable has more than two classes, stacked column still can show that more than two classes, but the complexity of the graph increases. So 3 or 4 classes can be represented as a stack collection, but other than two classes, I would recommend to go with a tree map, or you can also project the data as bubble chart. Bubble chart is where all data items appear as individual bubbles. The larger bubble depicts the maximum value, smaller bubble depicts the minimum value. Because we have only two classes here, we restrict or confine to a simple stacked column or stacked bar. Please check and confirm, participants. Could all of you get this visual generated on your side? A similar visual? Yes. Other participants who are trying to go ahead, please, if you have any issue, do not hesitate. We'll go slow because very important topic before going for predictive modeling. Yes, thanks, Atan. Great. Now we have this visual generated, right? So this is automatically clipped or attached to our project. So where to see that? On the extreme left-hand side, if you see the controls, this control which I'm highlighting is the exploration. If you simply click on this explorations, notice one graph you have already created currently, and it is now under the current project as a data artifact. So when you click on exploration, that graph is the current graph. Like that, you can create many graphs as and when required. They get listed out, piled up one after the other in the explorations section. Finally, after all required visuals are built, we can save the project by clicking on the save button. That's the approach. Now we have done something very usual. Another value added addition in Cognos is, after designing the graph, now most important point that we all should take away, I call takeaway, is we have to write the interpretations, right? Could anybody tell me from what percentage of male customers have favorably responded, participants? Anybody? What percentage of male gender respondents have favorably means said yes? Look out the graph. Tell me from the graph, what percentage of male respondents have favorably responded? Yes category, male customer. The pink one is female and the brown one is male. 13.2%, correct, Raibji. 13.2% of the given respondents in the data set have correctly favorably responded. Likewise, what is the favorable response by female? Anybody? Look at the favorable yes category responses by female gender. Very good, Satyam Joniji, for your quick answer. 15.2%. Sharadji also adds the value. Great. 15.2%. So which gender is more favorably responding towards the product of this company? Although there is not much significant difference in reality, female genders are more likely to have probability. Now, do you think this insight will add any value to production engineering team? How come this insight is connected? Think about it. Zoebji says, no, there is no connection. Others also. How does this insight give any knowledge to the production engineering team? In the market, yeah, because the difference is less, but probably can the production engineering team think different out of the box? Sharadji says yes. Ayushiji also says yes. Correct. Okay. Each one have your own opinion. But if you ask me as a common man, how I opine if I'm the production head of these companies, usually bikes are manufactured by many branded companies. Are they keeping gender in mind and manufacturing? Or are they going with uni-gender? 80 to 90% of the two-wheeler automobile industry globally actually goes with a default setting in mind. Bikes are meant for male gender. Do you agree with me? This might be the hypothetical thought, but the research here proved that more females are interested in buying the bike. Now, by looking at this visual insight, should the production engineering team should change their thought of action or not? Should change their thought or not is my question. Sharadji says yes. That means when the thought changes, actions also change. They could venture into a new product innovation, Zoebji, everybody, right? What is new product innovation? Besides manufacturing bikes for males, due to this visual insight, they could now also focus on new product offering by manufacturing bikes for females also. That's why Ayushji, everybody, why should boys have all the fun? This is how TVS has re-engineered their idea. Generating knowledge from the market data collected, pitching up the advertising punchline is the power of data science actually. Why should boys have all the fun? Imagine if this analytics was not done, Zoebji and others, if this analytics we did not do, how, if we were the production engineer, how the insight goes on, then we would go by default, right? We just opine to manufacture more male related bikes, but the data says the real truth. Contrary to this, on the other hand, let us do not underestimate the no cases, right? What percentage of female said no? Yeah. What percentage of female respondents said no, they don't want to buy a bike? Check out the illustration. 84.8. You're right, everybody. All others also, please try to respond to the questions to be interactive. Near 85% of the females said they don't want to buy a bike. Similarly, what percentage of male respondents unfavorably responded? Male customers or male respondents, 86.8, near 87. Quite not a huge difference. That means unfavorableness of bike buyer either by gender is insignificant. There is a high probability that either male or female can say no towards it. So this is highly challenging data for production engineering team. So do you think they should consider only one gender as their customer in the market, or should override that opinion? Finally, what do you say from this visualization? Should the production engineering team that procures raw material and manufacturing supply chain should only go with one gender in essence in the market, or they should make gender insignificant? From the imbalanced data set given to you, this is highly imbalanced. Why? Because near 85% of the sample data are unfavorable. Only 13 to 15 are favorable. Because of this imbalance, if you still keep gender in mind, that would be a very drastic decision. That's why at this point in time, by observing this, a hypothetical assumption could be scaled up, stating that let's make gender insignificant and try to produce equal probability bikes. You're right, Ayush. Gender is insignificant. Correct. This is how data-driven decision making should be entertained in the organizations. Is this point clear for all of you? The first research hypothesis between gender and our bike buyer visual insight generation. Correct. Now, I would like to open the floor for all the participants today to venture with me. The next question I would like to pose to all the participants is, children, number of children in the family of the individual, do you think will have any causal effect on bike buyer decision? That means our next visualization that we are going to create is between children variable and bike buyer. How I am drawing that? Because my relationship diagram, if you recall the initial relationship diagram, based on that certain assumptions I'm taking, value added to that, you can also continue others also. So try to project, yes, seating capacity. Because if the respondent has a small family, 1 or 2 child, psychologically might go for a bike. What about a family with more than 3 or 4 or 5 children? I mean, if the number of children in the respondent family are increasing, do you think psychologically they would prefer a bike? I'm not talking about any data characteristics, general hypothecation, correct. They may go for a car. Some recommendation from our one of participants say they may go for a car or other alternative, right? Satyamji, no means other alternative, right? Can be another better alternative. Let's see, discover that research here. So create a single card visualization, choose a new type here. You can again take a stacked column or stacked bar. Again, I'll go with a stacked column initially, because most of the insights come from this stacked column or bar today, because our data is, we are measuring the relationship between 2 categorical variables. That's most important. Why I'm choosing stacked column again, some of you might rethink, because the preliminary requirement is to find the relationship between 2 categorical variables. Now I have a stacked column. Could you anybody recommend me what field should I position in which sections? Our question of concern is to discover whether children, number of children has any effect on bike buyer. In the bar section, you recommend me the bike buyer. Okay, Zohebji, bike buyer in bars. Ayushji also recommends bike buyer in bars. I'll go with your suggestion, participants, for this time. I am depositing bike buyer in my bar section. Yes, please continue offering suggestions. What is the next field? Length field shall have children. Great. Length field will have children. So I drag and drop the children field in length. Good. Now, what did I get? Please check your visualization as per your recommendation. On x-axis, I have bike buyer categories. On y-axis, I have something unusual in thousands. But before addressing this, let me give a small tip, best tip practices for you. The number of children should be understood or not. So let me open the Excel sheet here. Raw data is always better to keep aside. So I'm opening my bike buyer 1 data set once again, participants. You can see that. Yeah, let me just protect it. Hope you all can see my Excel workbook, right? Yes. Look at the children column. The children column is a continuous data item. Does it have any range or scale? How to do that? Go to your data, put a filter, deposit a filter on the children column. If I drop down the filter, what are the minima and maxima values for children? That means a respondent can have what categories? Either a 0 child, 1 child, 2 children, 3, 4, 5, and some null values are also. Blanks means children column has null values. Some participants did not, some respondent did not give information on how many children they have. That means the minimum should be 0, maximum should be 5, correct. But if you see our graph that we have on screen here, if you look at the x-axis, it is yes and no classes, right? But what is y-axis here? It is showing the total sum. Typically, this has unusual representation. That's why we'll try to do some extra analysis here. Let me, instead of choosing a sum, let me take a count here. I'm trying some hypothetical chances. I have changed the function to count. From default auto sum, I have chosen count. Did the graph change anywhere, participants? Check out. After changing from sum to count, not much. But still this graph doesn't provide us the enough meaning. Do you all agree with me? Yes, this graph doesn't provide. That means there is some mistake that we could do initially. The only mistake correction is repositioning of the variables. This is called multi-dimensional modeling. If you see a Rubik's cube that your kids might play at home, the Rubik's cube has different colors on each face in different random heterogeneous. The player has to rotate the cube in such a way each face will have one similar color. If you imagine your bike buyer data set as a Rubik's cube, participants, we are rotating, pivoting the data to meet our research hypothesis. That's why what I do is I need to shuffle my elements in this stacked column. Simple shuffle will answer. So what I do is I'll try to start from scratch as the suggestion offered by our participant, the target variable going. But always remember, based on the need outcome of the visualization, there is no mandatory compulsion that always our target variable should be in bar section only. I repeat again, there is no compulsion that always you have to place the target variable in the bars only. You need to shuffle the locations. This time, what I do is I'll try to pick up my predictor. What is the predictor we are studying? Children, and then put it into bars. Why I'm taking children into bars? In a simple language, on x-axis, I want to project the children bars. 0, 1, 2, 3, 4, 5. Such projections I want to see on x-axis. Correct. Because the quantity of that data is limited, confined or finite. That's why this visualization is acceptable. But sometimes the spread of the data might be challenged. That means the number of children might be recurrent and more scalable. That means it has a distribution. Then we have to go for other variations in the tools. But for this point of time, I would like to project the number of children on the x-axis. That is category of number of children, not physically number of children, the categories of number of children ranging from 0 to 5 on x-axis. Then on the length field, let us place our target variable here. So vice versa. Unlike the previous suggestion, I am just projecting. Could you see now some visualization is generated here? On x-axis, what are these 0, 1, 2, 3, 4, and 5? Anybody? When I did this modeling visualization, I could project some visualization. Children count, category. It is children categories OFG. All participants can take down. The x-axis denotes category of children's. How many have 0? How many have 1 children? How many have 2? That implication that we are trying to, that imagination we are painting, sketching in the Cognos. Then, but all have similar height. Why all categories are of similar height? We need to do some minor revision here. Go to the bike buyer and change your aggregate function. Summarize, instead of count distinct, replace it with count. Replace it with count. Now, could you see something more meaningful here? The categories are now being projected. The categories of children are now being projected on the x-axis. But how do we want to correlate this? How do we want to connect? Our target variable is the rest of the job we have to do. Our target variable is not bike buyer. Simply drag and drop the bike buyer into the color shelf. Put the bike buyer into the color shelf. Now you get a beautiful stacked column chart. Everybody, we could now create a stacked column studying the characteristics between two categorical variables, namely children category with 0 child, 1 child, 2 child, etc. versus bike buyer class labels yes and no. Could everybody produce this visual? Participants, please confirm. Are you able to get this? Thank you, Sharadji, Riyaji, everybody, all others. I would be more happy to see if the names and popping new names are also popping. Those are doing hands-on. If others are observing also, you can respond. Yeah, great. Now we have done something great here. We could produce some visualization, but interpretation is the real art of the outcome. One has to also learn how to interpret, understand the visuals of the insights, visual insights. The green color on my screen currently, the green color bar depicts the no category of the bike buyer, while the dark blue one corresponds to the yes category. Could you figure out and tell me which category of children category of the respondent has more favorable towards bike buying nature? I mean, which respondents of children type have more favorably responded by saying yes? Is it people with 0 child, people with 1 children, people with 2 child? Which category? Observe the graph and share your interpretations. You're right, Aishji, again. Respondents who don't have a child, that means who have 0 children, the bar size of the S category is typically high. But at the same time, there is biasedness in the data also, right? While a 0 child has more probability of buying, also has equal probability of saying no also, right? Equal probability of saying no also, right? So there is a lot of noise in the data because we didn't had proper. That's why when you take raw data, it has got very challenging biased patterns. Similarly, when you move on the x-axis, Number of categories who have 1 child, 2, 3, 4. Where is the bar less? No category bar less in which one? From the graph, please pick out that child category where the likelihood of saying no is very less or unlikelihood is very less. Those respondents who have 5 children, you're right, Sharad Gupta ji. Those respondents who have 5 children are saying very least no category. So how to interpret is this one? The chance of correspondent saying no are less in case of those who have 5 children at least, but at the chance of saying yes is also less. If you want to add more rigor or further revise this visualization, what you can do is you can filter this. Like as analytical tools have the capability to filter the data, much intelligent tools also filter visuals also. They are called visual filters. How to filter that? I don't want to study both no and yes cases. Rather, I am interested in studying yes cases only. I repeat, imagine as a data analyst, we are interested in studying the yes data patterns only. So what we do is go to the bike buyer category and choose filter as your action to refine this graph. And in the filter, you can opt to filter, but this is a scale. So you can just go to the color card, color shelf, filter, and choose which cases? Yes cases only. I repeat, our intention is to study the yes cases. What are the possible cases of yes based on children? So go to the color shelf where we have the target variable, then choose filter, and then choose yes cases and done. Now could you choose here? Your graph is now filtered participants. Only the yes patterns are depicted. More yes cases are found in which child category? Obviously 0, followed by 1 and 2 children. So this is one insight that we could produce here in this project, which says that the chance of 0, 1 and 2 child can more likely to say yes. Yes, you're right, Joabji. There can be other significant reasons behind this. We further have to explore that. Why people with 0 child or 1 child or 2 without any hesitation said yes? Other dependencies might drive this pattern. We are still due of exploring that also. Hope everybody is clear how to apply the filter. If you want, you can apply the filter or remove it. You can see when I applied filter, we have included yes category. Now, if you go to the exploration section, please notice one after the other, the graphs are added to the exploration project. They are piling up in the list one after the other. Now, continuing going forward, let me give you another option here. But if you want to format the graph, you can always format it by going to the properties. Go to the properties section, show value labels. And if you want, you can show value and percentage. Value and percentage. 62.1% of the respondents who have 0 child have said yes. So this is one thing. Another important insight that I would like to share here to all the participants is, if you notice, Cognos has one special section in a EDA called analytics. Could you notice that, everybody? See the highlighted portion? There is one special section named analytics. What is use of this is, when you click on analytics tab, if any patterns preserve in the data visualization, they get highlighted. Tool highlights them. For instance, if I go to the stacked column, see currently I change my visualization from the gender versus, children versus bike buyer to gender versus bike buyer. Now, if I hit a analytics tab, if any hidden patterns are there in it, those visualization analytics are presented in the analytics section as a text statement. But this would come into play when you're trying to discover more rich data patterns, because why the tool is not selecting any analytics? Because there is no need for forecasting. All facts are clear. If any further in-depth patterns are there in your visualization, which are complex, which the visual cannot explain, when you click analytics, those patterns or those statements can be presented under the analytics section, which you can directly include in your presentation or research paper. That's the advantage of choosing the analytics section here. Right. Hope this is clear. Yes. Next, we proceed to the next visualization in quick time. I would like to offer the opportunity for our participants to show me a pattern between number of cars and bike buyer. Do you think the variable number of cars might have a influencing decision on bike buying nature? What do you say hypothetically, participants? If somebody already has a car with them, what is the chance of such a respondent buying a bike? So to answer that question, once again, you have to go to the data set. Always generate your hypothesis observations from the data set, data problem only. Here I have cars column, right? Could you all see my Excel workbook? I could share that here. Cars column is there. If you apply a filter on the cars column, what is the minimum number of cars a respondent possesses in the survey? 0 cars. What is the maximum number of cars that a respondent possesses? 4. Correct. 0 to 4. Now, a typical question to all the participants. If a respondent has 0 cars, you're right, Jayaji. If a respondent has 0 cars, Sharadji, everybody, can such a respondent would definitely buy a bike? What do you say? I don't have a car with me. Can I buy a bike? Is my probability of buying the bike higher? Maybe. Correct. Always the business outcomes are probability only. They are not realistic. We have to explore the reality behind the probability. Yes, there are other factors that drive this. Correct. But somebody already has 4 cars with them. Let us debate on the other side of the coin. Somebody has 4 cars. What is the probability of such a respondent who had 4 cars or 3 cars or 2 at least? What is their chance of buying a bike? Do you think psychologically they have a tendency to buy a bike? Yeah, some assumption, that is those who have 2 to 4 cars might have least chances of buying a bike because they already have abundant travel resources. But given these assumptions, is there a mandatory rule in the market? Those who have cars need not buy bikes. What do you say, participants? Others, please respond. Is there a strong mandate rule that those who have cars will not have? Now, if you see the real world that we are living in, each one of us have a car and a bike also. We will pick up our own travel means of comfort whenever required. That's why, how many of you think that cars variable, do you think will have any impact on bike buying decision? We still don't know until we explore. That's why our next choice of exploration is checking the compatibility with cars variable against bike buying nature. So let's take a chance with that. I would request all our participants to try to do some quick hands-on from your side also. So which chart would you select here, participants? First question. What suitable chart do you think would go work for this? Is it a stacked? Definitely a stacked one, Ayushi. So I can just go with a stacked one, but this time I can change. Instead of a stacked column, can I go for a stacked bar? What do you say? Yes, either a stacked column or stacked bar, both will serve the purpose for us. So this time I'll change the graph type as stacked bar. Right. Then stacked bar is nothing but horizontal representations. Column is vertical. Now, to understand the question again, we are trying to measure the relationship between number of cars and the bike buyer. So please offer your suggestions. Which variable should go into what shelf? Bar shelf will have what variable? Anybody? Bar shelf. Cars, good suggestion. Very nice, Ayushi. There is always a iteration need to be done in our mind and neural system to trigger the visualization. We can start initially with cars. Let us see the projection. Further, then we can change it also. Length is bike buyers. Okay. Bike buyer, I will put it into length as per your suggestion, ladies and gentlemen. Yes, I got something typical here. On y-axis, what could you see? On y-axis, could you see the distribution of cars? 0 cars, 1 car, 2, 3. Great. Yes. Y-axis has got. So this visualization is meeting our requirement to a certain extent. But do you think all projections are of the same height? Why? Because the aggregation is wrong. So to refine the aggregation, just go to the length variable and try to change the summary from count distinct to count. Yes, now we got something more meaningful. y-axis, the bar graph in the stacked bar, y-axis is our predictor, x-axis is our target. This is vice versa in column graph. 0 cars, 1, 2, 3, 4. But still, y-axis need to be more meaningful. So for that, what we can do? Any further suggestion, participants? Y-axis is meaningful, but x-axis is still not meaningful. For that, what we have to refine? Good suggestion, Zoebji. Very nice. Take the target into color. That is the target variable bike buyer shall go into color. That's it. Now we get a perfect stacked bar. Great. We got a stacked bar representing the relationship between the count of bike buyer by type and number of cars on y-axis. Could anybody understand this graph? I hope all of you got this. Please confirm before I go for interpretation. Please make sure all the participants who are doing hands-on, who are following me, are very clear on this. Yes. Yeah, you can set the properties. You're right, Satyam Sanidhi. You can set the properties, show value labels, and pick up your choice, anything. Right. Beautiful. We have got some values and some percentages. Quick interpretations are required in the chat window from our participants. Yeah. How much percentage of favorable is you could find in this graph, and that too from which car category? Which car category respondents highly favorably responded is my question to you all. Check the graph and answer. The category 0 to 2 cars. Okay. 0 people having 0 to 2 cars have highly favorably responded. And the maximum responses, as said by Aishiji, came from category type 0, 29.9%, near 30%. Okay. Mamtaji says 27.7% of the people with category 2 cars have favorably responded, 27.7%. So what suggestion as a data analyst would you like to give to this bike manufacturing company? In future, the bike manufacturing company should target which type of respondents in the market? Is it to everybody or particularly somebody? All participants, try to give a try on this question. If I have 7,000 customers respond in market, should I target everybody? Of course, the product is for everybody, but the buyers are somebody only. Out of the everybody, true buyers are somebody. Who are that somebody seriously here? Riyaji, who are that somebody? Ranuji, everybody. Please check that. Probably those somebodies are those who have either 0 cars or 1 car or 2 cars. Those who have either 3 or 4 cars, the probability of those buying bike is very low. But the probability of they saying no is also very low. A very great challenge for the production firm is look at category 2. Category 2 has 27.7% positive responses, 38% negative. The longest bar is in category 2. So focusing category 2 is an opportunity or risk for the company. What do you say? Focusing on customers with 2 car category, is it a risk for the company or opportunity? So the dependency should also be checked. If you look at the graph visualization, it clearly states a fact as number of no cases is quite higher. In which category? Unfavorable responses are higher and higher in which category? Type 2. Can be risk-prone decision is what the analytical insight means. I hope, Zoebji, in addition to your visual insights that you initially presented to me at start of session, could you discover how we are adding more value with our visual insights in the project of EDA? Even all other participants also? Yes. The more you explore, friends, the more you discover in research, I say. Add drop by drop knowledge insight and become the science of the data expert, data scientist of the world, I say. This is how the motivation should drive for our research. The journey, the facts are simple, but the knowledge is an explosion always to discover. Right. Going ahead, you can continue your journey with rich visual insights. To add one more, shall you permit me to show one more insight, dear participants? Please respond. Shall we add one more knowledge insight drop to our rich project? Yes. Then we will move on to data pre-processing quickly. Thank you all. Great. Thanks your turn for all your unquenched thirst for knowledge through data analytics. Click create. I'm going ahead with one more hypothesis. The next one is, so far, if you see the visualization that we have learned in this session, either gender versus bike buyer, where our predictor is categorical, target is also categorical. Similarly, we had seen the commute distance versus bike buyer, where the predictor is numerical and bike buyer is target. That's why analytics fit for any combo, whether categorical to categorical, continuous to continuous, and continuous to categorical, because rich patterns lie in all possible dimensions, I say. Our next proposal of visualization is, how many of you think age of the individual is also a critical factor in deciding bike buying nature? Do you think age has certain relationship with the target? What do you say, participants? Age of the individual. Yeah. Initially, not much. Okay, initially, not much. Other participants, what is your inclination regarding the age predictor on the outcome? Now I'm sharing the Excel sheet in front of you. Excel sheet in front of you. Age column is also there. You can see the age column here, right? When I click the filter, I have got all the ages sorted out. I got all the ages sorted when I apply the filter. Alternatively, you can do the max and minimum functions or write queries in your Cognos. Now, from the observation, could anybody tell me, like in the given illustration, what shall be the age? How can we decide on the age parameter? If I would like to take you all to Cognos again, let's go to the exploration section. I'll activate my assistant first. I hope you all can see my Cognos screen again. Yes, I'm activating the assistant. I would like to type some query. Minimum age. I'm just hitting one query here, minimum age on my screen. Run my query. So I would like to know what is the distribution of the age. The minimum age of the respondent is how many years, participants? Please see the answer given by the Cognos Analytics Assistant. As per the data set, the Cognos Analytics Assistant found that the minimum age of the individual was 25 years. Clearly, you could see the minimum age is 25 years, participants. Correct. Like that, find maximum age. Maximum age. What is the maximum age of the individual? Let us see. I am just doing boundary value analysis here, BVA. 96 years. That means all the respondents' ages are fitting between, what is the age group distribution? Anybody? 25 years to 96 years is the age distribution. Given this insight to you at hand, now I am typically challenging all our participants here. What is your assumption about the age variable? How can age affect? Any psychological thoughts on this? Is it younger age individual who might be eligible for a bike? Is it middle-aged individual or elderly aged individual? According to you, psychological, if you're the production engineering team head, what is your target age group? Without any analytics of the data, what is your ideology? Anybody? Or do you think all ages are eligible for bike? What is your presupposition? All the dear participants, please try to think on this important insight. Initially, if you ask me as a common man, you're right, Aishuji. Because business has to target all ages, I will be targeting all ages. Aishuji also targets all ages, it seems. Other participants, all ages. Sharadji has a different opinion. Younger age individual might be his target. Satyamji also says, Satyam Soniji says 20 plus might be the target. Correct. Each one of us have certain opinions about data. But what the real fact? Let's discover that. Zoebji goes with a dispersion 20 to 40. Great. Each one of you have some thoughts around it. Thank you for your inputs. How to discover the real artifact of the age versus this thing? 20 to 96 is our distribution. For that, I'll first go to my data source. Everybody, now we'll do some different game here. So follow carefully. I just clicked on my sources button. I have the age. Most analytical tools, whenever they are working on distribution of the data, age is a continuous variable, but our target is a category. To model the data effectively between a distributed continuous variable and target, a wise approach is transform your continuous variable into categorical variable. I repeat, if you would like to project 7,000 data points, like each customer age versus bike by response, do you think that graph would be very typical or not? Yes, that's why to avoid the complexity of the visualization, a recommended approach is we convert our continuous distributions into categories. Yes, we try to transform some pre-processing I'm doing here. I would like to convert the age variable into groups of ages. That is binning. Data binning is done here, or data categorization. How to do that? Yes, creating groups is a very great opportunity. You're right, Revji. Click on age parameter or right click anything. And in the menu, can you see one option is available, create a data group. First, go to the sources section, participants. Always click on sources, where you can see your variables in the list. Click on age column and right click and say create data group. Cognos allows you to create some data groups. What is the minimum age? 25. Maximum age was 96. I would like to create some distribution groups. This is again, each individual can have their own thoughts of creating the bin ranges or class intervals. So I would like to start with more dispersion in the data. So you can increase the number of groups as and required. How many groups you want, you can increase. Default is 5 groups for Cognos. You can increase or decrease it using the increment decrement buttons. Right, could you all see the screen? Please make sure all of you are in the screen, participants. Check and confirm. Are you in the data creation group? Just right click on age and say create data group. So how I'm creating is I'm planning to create 9 different groups and scroll up and down on the right hand side. You can scroll up and down. Start from the bottom. Some default values are there. You can use them or you can create your own. I say 20 to 30 years. First group is 20 to 30 years. In intervals of 10, I am planning my groups. If you want, you can take intervals of 20 also for simplicity. 30 to 40 years. You can quickly add those age groups here. 40 to 50 years. Keep building your age groups, participants, as per your class intervals. Yeah, I am creating the age groups, Aishuji, for information. As age is a continuous variable, it becomes very difficult to project each age versus each response. Do you agree? 7,000 respondents are there. Projecting each age versus each bike by response would obviously be a complex visualization. That's why for optimization, we would decompose the age variable into groups. How we are decomposing or optimizing? Right click on the age and choose create data groups. Projecting data groups makes a numerical variable into categorical. Yeah, correct. The actual data are being made fit into class intervals, Aishuji. Each individual age is being binned or modulated into class interval. Each class interval depicts a age group in reality. So I am just creating some groups here. Hope you are clear. The participant who asked the question is clear, right? Now we are trying to fit those age groups. I have taken 9 class intervals here for my convenience. You can take as many as you want, participants. 20 to 30 years, 30 to 40 years, 40 to 50 years, 50 to 60 years. So you can keep creating your class intervals for the ages. This is like frequency class intervals in statistics, we call. You're binning the data into class intervals, 70 to 80, 80 to 90 years, and finally 90 to 100 years. 100 years. Why? Because my upper limit is 96 and lower limit is 25. The boundaries of the class intervals I have chosen from 20 to 100 in multiples of 10. Please create the age class intervals or age groups by requiring the number of groups and then click create. And then click create. Now notice something new introduced here. The original variable is age variable here, but now we have added one more new column to our data set. See the highlighted one. What is the newly created field or variable to our data set, participants? Anybody? While age is the actual variable, age group is the calculated field or user created field. That's why customization is a great possibility in all the analytical tools that we have in the market. Sometimes we have to work with calculated or user created fields also. So simply, this is how we created the age field here for our convenience. Now, can we project those age groups on the visualization? What do you say, participants? Let's start projecting those age groups. Let's start building our age groups. I prefer a stacked bar here again, or you can prefer a stacked column also, whatever you are comfortable with, stacked column or stacked bar. Instead of putting the age, each individual age, can I now show my age groups on the visualization? What do you say, participants, everybody? Rather than showing each individual age of the respondent, I am simply optimizing, minimizing my graph complexity by dropping the age visibility, correct? So that each individual will fit into a class interval. And then I'll take a count of byte by. That is how the visual framework has to be coined. Now drag and drop the age group. Can you suggest where age group can grow? Anybody? The column newly we created just now named age group shall go into bars, right? Great. Then what is our target variable? It is bike buyer as usual. So we will make it the length here. Bike buyer is length, participants. But now you can see your y-axis. Age groups are displayed, which is what, of course, we are exploring. All respondents' ages are displayed as age groups. Let us do some revisions in the aggregation summary and change the summarize to count function. To distinguish the graph, to be more precise in accuracy, we will try to put the bike buyer in our color shelf. That would produce a stacked bar. This is how the distribution of individuals in by age group versus responses. Age group was created and was put it in the, the last stage also, yes. 89 and above. All those who are above 89 are fitting in the last category. Yeah, now we will comment on the interpretation strategy one by one. Hope all participants could generate this graph. Please confirm. A stacked bar depicting age groups of the respondents versus favorable and unfavorable outcomes of bike buying nature. Correct. Quick responses are needed now. Find out the most prospective age group for the company for sales. What is meant by most prospective? That means which group more responded yes, which age group respondents more favorably responded. That is called prospective age group for the company, we say. Prospective buyers. 30 to 40 years. Okay, Mamtaji and Aishuji says 30 to 40, right? So if you want to add more light, you go to properties section as usual and show value labels and choose the item value and percentage of color. Yeah, this will add more richness to the graph so that you can draw some interpretations from it. Just go to properties section and hit show value labels, correct? So could you discover now? Highest percentage of favorism comes from which age group? 30 to 40. 33.2% of the respondents of the age group 30 to 40 said they want to buy bike. Do you think, participants, this can be one of the most important insight that can be shared to the production, marketing and sales teams also? What do you say? Think out of the box. Correct. If marketing and sales teams are given this insight, they know whom to target first. That age group they'll focus. How this insight will be useful to production team, engineering team, anybody? How the 30 to 40 year age group, which is more favorably responding to our demand by, how can this insight be useful to the production engineering team? I'm asking. Do you see the innovation in automobile engineering nowadays, whether it is two-wheeler or four-wheeler or whatever it is? Are products being manufactured suiting to the customer requirements or not? Tailor-made engineering we call in automobile industry. Tailor-made means all the features to be incorporated will be suiting to that age group. If any company can build a product, design, manufacture such a product which meets the requirements and expectations of the customer, can such company can become market leader? What do you say, ladies and gentlemen? Obviously. That's why, do you recommend data-driven analytics for manufacturing firms is my question of research. Do you think analytics with data can drive manufacturing automobile engineering industry greatly? Correct. Without a doubt, yes. Thank you, Zaibji. That's why IT, application IT should be useful for other industries also. Then only it is true IT, I say. See, we can design a mobile application, web application, or a software that can do data and information processing. But is there a technology that can not only process the data, but analyze the data, crunch the data, synthesize the data, and then give data-driven decision-making empowerment also? If there is such an IT, then under the umbrella of emerging technologies, it is data analytics IT, I say. I hope all of the participants are understanding where I'm pitching upon the importance of the new IT in this era. Correct. Good. So I hope this journey can continue here because more explanations. Zoebji and others also participants, can you take forward this journey? I will give you 24 hours of time. Can you add more visual insights to this project from your side and take it forward on a higher note, right? Okay, I would be happy on the last day if all the participants would do complete this project as an assignment from our side and show it to us on the last day, like what value addition each one of you contributed in this project as a learning outcome, because each project should have learning outcome. An FDP should have not only have learning objectives, participants should also have learning outcomes also. Then only it is fruitful FDP, I say. Correct. Let's see. I'll give you some days of time. You can do your exercises, drill down, and bring the facts to us, and you can share your screens when asked. You can show more insights on this project also, right? Now, without further ado, let's save this exploration, because unless you save, that will remain ignored. So how to save that? Simply click on the save button on the top left corner. You can notice the save button here, which I'm highlighting here. So you can click that and provide a name for this. Yeah, we will provide more data sets, Ayushji. At the end of each session, the support team will mail you. Shivam would be mailing to you much more practice data sets of real world, challenging all the learning capabilities of our participants to enhance more richness of the program. Right? We would give you more rich assets of data. So how to save this? You can simply give a meaningful name, bike buyer data exploration. Bike buyer data exploration, or any other name, meaningful name also you can give. Make sure you save your project under which folder by default? My content. When you are saving under my content, it is private under your repository. If you're putting in team content, other collaborators can also access this. My content and click save. So click the save button, provide a name for your project and save. Why we are saving is, in future, in the coming day sessions, if you want to build a dashboard, you can build a dashboard from scratch by creating all this visualization. Or additionally, another great benefit in Cognos is, could you all see this pin icon which I'm highlighting here? The pin icon is available, participants. Could you see the highlighted one? There is one pin icon here, and there is also one pin icon here. What is this pin is? It is like a shortcut. Whatever visualizations we just now created visualization, they are available under exploration. Do you want to see each of these visualizations in your dashboard? Are you interested to attach, pin, connect each of these visualizations on your graphical dashboard, participants, and make the visualization more dynamically interactive? If that is your objective, you can save these visualizations by clicking on the pin. For example, if I just click on this pin button on the toolbar or on the left side assistance, immediately the current visualization, if my current visualization is this and click on the pin button, notice Cognos is processing the pin. Cognos is processing my pin. Second visualization, I highlight in the row and click on pin button. That is also being processed. The advantage here is tomorrow, if you are building your dashboard, day after tomorrow, if you are building your story point or report, no need to build the entire project from the scratch. No need to start the project from the scratch. All you need to do is extract the visuals from the saved pins and build your dashboard within less time. That's the advantage of pinning the objects visuals into my pins. This section is called my pins, right? But if you don't pin them, still also you can build your dashboard, still also you can build your story, provided you have to do the entire activity from the scratch. I hope all our participants are understanding the benefit advantage of pinning the visualizations to my pin section. Simply nothing but future reference, referencing the objects for future activity. So we have completed the exploration part. Now let me take you all on the journey with the data pre-processing quickly. Yes, all the pre-processing now comes into play. If you recall, in this given data set of bike buyer, there are many hurdles with us. So far, we greatly visualize our data, but what is the biggest hurdle we had, participants? Missing data are there or not? Yes, there are a lot of missing data available. How to deal with them? The second important step in our analytics, data analytics, using Cognos or any other tool is data pre-processing. What is meant by data pre-processing is it is a part of data mining activity where users try to discover unidentified patterns and then try to take an action on them. That is, transform raw data into more meaningful formats. Before we learn how to pre-process, first question that you all should ask me is why to pre-process the data? Real world data, do you think is incomplete? As the bitter reality you saw today in bike buyer, the data is not 100% completely available. Missing values are there, incomplete. Is it noisy data, ladies and gentlemen? What is noisy? Some categories say yes, some categories say no equally. That is called noisy data. Is data inconsistent? Yes, there is some lot of uncertainty in this. That's why, do you think raw data is of high quality or not of high quality? Never real world data that comes is of not high quality at all. If that is high quality, half of our problems are solved in research. That's why no research, whether you're doing a doctoral program or postdoctoral thesis, or you're trying to do a consulting activity, no real world data are highly qualitative. No sample is highly qualitative. We need to do some extra efforts to make the data of high quality. That's why, keeping this object in mind, we have to pre-process data. How do we measure the quality of data? There are certain characteristics. Data should be accurate, completely available, should be trustable, consistent, believable, and should be accessible and researchable and interpretable. If data has these qualities, then only it is suitable for analysis. And how do we make our raw data possess these characteristics? Although it doesn't have essentially, let's take a journey. Data pre-processing essentially has 4 important steps. First one is wrangling or cleaning the data. Second, integrating data from multiple sources, because the essence of business intelligence is what? Combine various data sources and then make it a homogeneous. If required, try to change the description of the data by transformation. If required, reduce unwanted data, remove unwanted variables. Like Jobji, you can said, others also said, is that 89 years and above, where we saw the visualization, where the length of the bar was quite less. Do you think such age people should the company focus on in the future? In our visual recently, a minute ago, 89 years and above category were very less. Why should we focus our efforts of marketing on that age group? Can we exclude? We can exclude. But one important point I would like to bring to you all to your notice here. There is a person whose age is 95 years in the data set. Try to understand this question carefully, participants. There is an individual respondent whose age was 95. When the market research team asked that person, do you want to buy bike? That person said yes. Do you think, can we believe in that data? Do you think, can we believe in that answer given by that person whose age is 95 years? When asked, he said yes abruptly. Mamtaji says some good word outlier. Okay, but my question to you all is, should the production team believe that as an opportunity? 95-year person. How can a 95-year person eligible for a bike? Can be a psychological question, right? But if you rethink from the question again, participants, what is the question asked by the company? Do you want to buy a bike? They didn't ask, do you want to ride the bike? Is it so or not? What do you say? The question asked was, do you want to buy a bike? Not do you want to ride. If you do want to ride, that person said that is really outlier. Mamtaji, do you now agree? If the company ignores that person, if the company ignores that customer, that believing that, oh, 95-year person is not eligible for bike, will they lose one customer or not? Participants, what do you say? Maybe that person will buy the bike. As Zoebji said, he will gift that to his grandson or granddaughter. This is the way of analytical thinking from a business always. Never underestimate any data point, dear participants, because every data point is a gold mine of opportunity for us. But sometimes some data point doesn't add any value. We can exclude them by data reduction. This is called dimensionality reduction in analytics. Techniques like principal component analysis in statistics will have such applications. But in this session, we are limiting our experience only to data pre-processing only, or data cleaning. We are not focusing on integration, transformation, and reduction. Those are other high-end topics that might come up in our life soon. Data cleaning is only what we are focusing on. So how to clean the data, where to begin with on a quick approach. Let me show the reasons. Two types of challenges need data cleaning. First, I will pitch it on quickly. What type of actions require data cleaning? One, columns that have missing values, columns that have noisy data. Noisy means two extreme values are inconsistent. These are the cases in the data which requires data cleaning. I repeat, these are the scenarios where as a data analyst you can apply data cleaning where columns have missing values, noisy or inconsistent data. How to begin with? Yeah, that's what I'm coming with. First, to begin with our data cleaning, one must start with understanding how data are missing. Essentially, there are 3 to 4 varieties of missing data. One is missing completely at random. Second one is missing at random. Third one is missing not at random. To understand this, let me present to you all one simple example on screen. The conventional methods, I'll say. The conventional methods are, if any row or column has missing value, our chances are, starting with the first one, we can delete that row or column. The first simple chance is any column or row has missing value, participants, we can delete that row or column. But if we delete that row or column, is it a right practice? If we delete that, what happens? Shall we lose some data or not? What do you say, participants? Obviously, we will lose some valuable data. So the sample size decreases. Never delete data. Your sample size decreases, so analysis goes wrong. Then how to tackle or handle that issue? Other methods are there where we follow imputation method. The word imputation means replace absent value or fill the absent value with some known measure or statistical value. So for this, recommended practices are, a data analyst can replace a missing value with mean imputation. Mean means fill the missing value with average, or median imputation, or mode imputation, or any other technique. So any other technique which adds value to the data cleaning process. For a understanding how mean and median or other imputations look like, let us see that. Here I am presenting a snapshot of our data. Please look at this data having column subject, ID, age of the individual, gender of the student, and something, income of the person. if you carefully observe this data set, do the columns have missing values? Yes. Age column, if you see participants, has one missing value. Gender column has one missing value. Income has missing value. Now, if I start using deletion approach, I can delete the age column, I can delete the gender column, I can delete income. Then what remains for analysis for me? Anybody? What do you say? Does anything remain for me to analyze here if I delete those columns because of missing value? Nothing remains. Correct answer. Other than column deletion, if I go for an alternative method like this, what is alternative method? Rather than column deletion, I'll change my approach here. I will delete that row only. Yes, you're right, Zabji. I will delete that particular row. So rather than column deletion, I'll go deleting first row, deleting the second and third one also. So out of 10 rows, how many rows I'm deleting, participants? 3. I am left with 7 rows only. So 70% of data is there for analysis. That's why if you don't want to lose 100% data, and at the same time, we don't want to delete row or column, there is another beautiful approach for our data imputation, that is imputing or cleaning data, wrangling data, cleansing data with imputation techniques. So what we do is here, we will try to do some statistical techniques. First, for numerical columns, if you see here, quickly watch here, for numerical columns, how can I fill the missing value here? Probable chance is I will take the average of available values which are present. Try to understand the essence, everybody. I will try to take the mean average value. I will calculate average of available values. Substitute that mean in place of missing value. This is a most commonly used approach. But why I am trying to take mean? Always remember, something is better. Rather than filling the data with some unknown value, ad hoc, imaginary value, is it better to substitute the mean there? Why? Because in a statistical distribution, all real world data might either lie close to the mean or far away from the mean. The mean becomes the measure of central tendency. That's why the topic measure of central tendency was introduced in statistics, because by and large, real world numerical data will have a certain relationship with the mean. That is one way. Other way is you can use, other than mean, a median also. What is a median for a numerical data distribution? Anybody, according to your experience? Median is the middlemost element of the data set. Median means the middlemost data point of the distribution can be used as the replacement. Great. For numerical values, we understood what are the techniques. But let me challenge all here to see your participation. If the gender column, is it numeric or non-numeric? I mean, is it continuous or categorical? Observe it. Gender column is not numeric, it is categorical. But there is one missing value here. How can we fill it? You cannot apply mean function on categorical columns. You cannot apply median function on categorical columns. Then how to resolve this? Go with majority. Correct answer. In simple language, majority means most repeated item. Check the frequency of most repeated item. Which gender is mostly repeating in the data set? Imagine if it is female, we'll write F here. If it is male, M here. There might be a question to some of our dear participants. What if the ratio of M and F are both equal? Then which one should I take? I have this question for you all. Imagine if M and F both are equal, then which one should I take? There is a biasedness. But tell me, participants, is there a data set that have equal distribution of gender? Is there an organization in the world where the number of gender are same in the organization? In real, I'm talking. Certain facts I'm talking. Very unlikely, correct. Let us go with myth. Let us go with perception also. The myth is the fact. No organization will have equal number proportion of male, female. Even if it has also, the alternative is one time clean the data with male as your opportunity. one time clean the data as female. So your original data set is decomposed into how many subsets? When you are cleaning, filling the data one time with male, one time with female, 2 subsets of the data according to the gender will approach. So you have more robust analytics to be done on this. I hope everybody is clear on the basic part of the data pre-processing, right? Then let's move on to Cognos and quickly implement it before we close out for Q&A. Right. Let's go here and switch to my Cognos analytics. Here I go with my Cognos. Let me erase this all. Right. Now, how to begin the data cleaning? Currently, I am in which screen? I am in the data exploration screen. Let me close this screen. How to close? Click on the Explorer. That's it. Bring back to data module. To perform data cleaning in Cognos, make sure you create data module participants. How to create data module, everybody? Click open menu, click on new command and choose data module. Once you click data module, choose your data set. For this project, which data set are we using? By buyer. Correct. One activity I will show, rest I will give as a practice of work for our participants to clean the data. Let's start with first variable, ID. Do you think ID is a useful variable for us to start with? ID is unique, so we did not worry about it. So let's exclude. But let me start with children. For one numeric variable and one non-numeric variable, I'll show in quick time. Rest, I can leave the chance for you all. First numeric variable, which is causing trouble for his children because there is a null value participants. You can see the highlighted one, there is null. So how shall we replace? As discussed, we will take the mean of the number of children for each respondent and substitute the mean value. For that to achieve, what we do is right click on children variable. Everybody follow the on screen and accordingly operate. Finally, right click on children because that is the variable that we are cleaning. The last option in the menu is properties. You could see that the last option is properties. Please click properties. When you click properties, notice on the right hand side, properties dialog box open. Would you all get that? What I simply did is right click on children because that is a variable I'm cleaning and go to properties. In the properties section, notice you have an option under expression where I'm highlighting view or edit. Could you find that? When I right click on properties under expression, I have view or edit. So now we are going to create a user defined expression for cleaning our data. That is transformations are being performed. Just click on view or edit. Just click on view or edit. Please confirm participants whether you are all in the edit calculation window on your machine also. Choose one variable of your choice, right click on it and go to properties section. In the properties, there is one field called expression. Click on view or edit. Under view or edit, Cognos gives you various transformation techniques, data pre-processing techniques, which include function. So you have to click on the function. We are now transforming the data using built-in functions. So click on the F button here, where I have highlighted the button labeled F push button. We need to click on that. So I just click on F button here. We will do fetch functions. Okay, let me recheck again. I just choose my children variable, properties, go to view or edit. Currently, which variable am I just operating? Children is the data item that I'm going to click on children. Unable to establish metadata. Check on your side also. Could anybody get this error? Somebody will get list of functions due to some connectivity to the metadata function explorer dialog box. I'm not getting. Zoebji, can you share your screen, sir? I'll be using your screen from here on. To save our time, please share your screen, Zoebji. Thank you. Correct. All participants, I hope, can also see Zoebji's screen. So when a participant clicked on function, he got a list of functions, operators, summaries, constants, everything is there. Here we need to first of all check whether children value is missing or not. Right. So please click on constructs option. go to constructs. In most programming languages, we have decision constructs like if function, if then else function, if else condition, search condition, case. Like most programming language have, Cognos also has this programming decision construct capability. So now what we have to do is, I would like to check if children variable has missing values or not. If the condition is true, then I have to clean that. So to make this happen, please drag that if then else onto the expression canvas and drop it there. Yes. Simply we clicked on function button, participants, and then if then else we used under constructs category. Now we have to mention one condition. What is that condition we have to mention? Okay. Cut paste that children, which is on the extreme left hand side. Select that. Yeah, select children. Control X kar dijiye. Control X and paste in place of conditions. Very nice. All participants, please follow the on-screen instruction. The children column is now being given. Actually, we have to check whether it has missing values or not. Please delete that is equal to, sir. We have very simple functions, right? If children. Now go to the operators tab under functions. Click on operators first item. Slowly scroll down. Relational operators are there. Logical operators are there. Slowly scroll down and find one operation is missing. Cognos has one direct function called is missing. Drag and drop it adjacent to children. Very nice. I repeat, participants, first we selected constructs and choose an if then construct. Then we went to operators, and which operator we selected? Is missing. If children is missing, then what should we do? Delete that expression. Actually, we have to take the most repeating gender. Imagine in this data set, more males are there than female. But how can we find that? Recall your EDA, participants. In the EDA section, if you create one bar graph or column where you could find either male gender are more or female are more, or female are more, male are more. So from the EDA graph, can we figure out which gender is more in the company? What do you say? Yes, easily we can find out which gender is more. That most repeated occurring gender we can replace here instead of the expression. That is one way of cleaning the data. But when we do that mode imputation, that is called mode imputation actually. That means replace the missing item with most repeated gender. But if I do that, is there any problem to the data? What do you say? Already the data is imbalanced, participant. Imbalance means one gender is more in the data set, one gender is less. Due to this kind of mode imputation, is there a possibility that our data might become more imbalanced? What do you say? Your answers on screen. There is a chance that by mode imputation, we can achieve the cleaning, but due to that, more noise can be added. In such case, simply what we do is, instead of the expression, delete that expression. And delete that expression. And simply you type there within single quotation, other. We will give some label. We will give some meaningful label to missing data. Rather than blindly imputing with most common category, which is one common imputation, we'll simply give one meaningful label. Not male, not female, others. That is the then case. Else means what? If no missing value, keep the column as it is. That is, take the children column directly. Type children, yes. So what does this statement tell us, participant? What does this expression tell? Simply, I'm just summing it up finally. If the column labeled children is missing, means has missing value, then in place of missing value, replace with what label? Others. Else means, what is else part? If the condition is false, leave the children column untouched, undisturbed. Right. To keep this simple, hit an enter key before then. No, hit an enter key before then, sir. Similarly, hit an enter key before else. Great. Now you could see you have constructed your if else condition. How to run this command? Go to the toolbar tab, click on the validate button beside the eyelid icon. Toolbar, right side wala. Come to the third one, sir. Third one, validate. All of you, please note this. Please validate. The expression is not valid. some other errors are there in it. If children is missing, then others else children we have taken. So the if else condition is missing some additional construct. Okay, but once you run this, the condition is validated and click OK. Do you know what is the outcome of this? I'll show it in tomorrow's session also. Data cleansing more clear. What happens is the wherever children is missing, we will replace. But why we got error, I'll tell you. We are using an others, which is a categorical data item, whereas children is numerical column. To overcome this, what I do is delete that others now. That's why selection of the missing value should be. Now we will apply a mean function. Go to the summary section now. Go to the summary section and choose average here. Yes. Now we will solve the issue. Average. Average on which column you are applying? Children column. Correct. You're right, Sharadji. Children column. In the else part will be children only. Based on the nature of the column, you have to choose the imputation correctly, because children was numerical and we are trying to fit a categorical. Cognos did not accept that. There are multiple summaries for information. Children is missing, then average children else. Now validate, Zoebji. Validate that function. Now it will work for us. Yes, the expression is valid. Perfect. Click OK finally. Great. Click OK finally. And now what did you notice in the data set, ladies and gentlemen? Earlier, where we had a null value in place of children, was it replaced by the mean value of the children? Could you all notice that? This is called mean imputation. Filling the continuous data with mean. Simply for a categorical column where you cannot do mean, median, you simply put by default mode, but mode is not available in Cognos. What you can do? Type others. Type a meaningful label. The same if else condition can be executed for categorical variable also. Simply you can type the category label name, which will be replaced in place of the missing value. However, I will be demonstrating that tomorrow from my side also. So this is a very quick overview of identifying missing values and cleaning. But apart from missing values in the data, we also have some other problem, outlier. For example, in yearly income, is there a value 0 there? Please look at. Correct. Shall we consider this person as a buyer or ignore that person as a buyer? Final question for our participant before going for Q&A. After looking yearly income 0, shall we ignore this person from our business or still consider is my question. Imagine if we ignore, as I already told, we will lose one customer. If we consider what is use of that, to answer that question where we have extreme values, too low or too high, that is outliers, which lie far away from regular data, we will detect those outliers in EDA and we will learn techniques how to handle them in tomorrow's session, followed by dashboards also, followed by dashboard management. So for the today's session, this is the very in detail explanation on the need of EDA and a quick glimpse outline of data preprocessing essence and basic applications in Cognos using data module management. Shivam, if you're there, you can open the floor for a quick question and answer.
Yeah, so yeah, hi dear participants. I request you all, if you have any questions, now we are open for the Q&A. So I'm giving a permission to give you all for
any questions related to the discussions done for can be presented.
Sir,
the chat also. Yeah.
So the pin feature, is it helpful for some other dataset projects also or for the same dataset?
See, good one. Pins refer to customizing the visual elements so that they can be switched over to the current project elements, or in real time when you are using Cognos at your organization, you can be the admin account and you can add people, sir. Whoever is asking this question, you can manage people. So to show that, let me just check it here. One final share I'll do. Let me close this. I'll just go to the menu. Can you see the manage section here, sir? What I'm pointing out? In the manage section, can you see people are available here? The people icon. You can configure and create people accounts there and try to set up a collaboration. in case you want your visual elements to be accessible, shareable to other collaborators in the project team, do you think now pins will be very useful for them also? What do you say? So any other person who want to use your visualization can go to my pins and pull out the visual artifact and use in his or her project also. Would save the project development time or not? Otherwise, everything has to be built from scratch. That's why Cognos is a real-time web-based analytical tool on collaboration basis also. Yes, they should be on the same project. You're right. Collaboration means similar project. Artifact should be between the team members. Yeah, I hope you are clear, gentlemen. The answer. Any other question? Let me know.
Yeah, dear faculties, if you have any other question, we are open for Q&A. I request you all to please post your queries, or you can unmute yourself to ask the question.
A true web-based BI tool that can add more value to rich insights through visual analysis, data management, pre-processing, and much more interactive, presentable, dynamic BI dashboards reports, all in one single place. Cognos analytics from the IBM, phenomenal. So thanks for the extra minutes, participants, for your great patience today. I hope all of you could get a sense of the discussions. We would expect all the participants to take the journey forward. Shivam, I will be sending some more extra practice data sets. You can intern forward to all our participants and make sure all of them are going through and participating, so that that will enrich their learning experiences for a better outcome.
Sure.
Yeah. So that's all from my side for this evening on Monday, participants on day 4. Concluding, thanks a ton, everybody, for this wonderful evening.
Thank you so much, sir, for delivering such a wonderful session. And I hope everyone, all the faculties are very clear with day 4 itself. Yeah. And if you face any difficulties or if you have any questions, we are ready to take your queries, or you can post your queries into the group as well. So thanks to all the faculties who stay with us after 8 p.m. itself. So thank you very much. And thank you, sir, for the wonderful session.
Thank you, ladies and gentlemen. Have a great evening.
Thank you. We are now going to sign off. Thank you very much.